Hi everybody, this is Mrs. V. Banureka. I am here to give an overview on the various machineries, equipments and automation available for apparel production. Gone are the days of waiting for a brand new dress. Today's technology has reduced this waiting time between a dress you dreamt of and the same dress that you wore. Today's apparel industry is nothing less than a fairy's magic wand. Automation has nevertheless reduced the lead time and has improved the productivity along with the quality as well. Fabrics are very unique from other raw materials due to their limp nature and therefore need a lot of manual manipulation. So now we are going to have a look at the various machineries which are available to manage this tough kind of a raw material that is the fabric. So let us have a look at it. The apparel manufacturing process happens in three stages, namely pre-assembling processes, the assembling processes, and the post-assembling processes. All the three stages involve a wide spectrum of machineries and equipments, and most of them have possibilities of integrating automations. So now we are going to have a look at the various machineries which are available to manage this tough kind of a raw material that is the fabric. So let us have a look at it. The apparel manufacturing process happens in three stages, namely pre-assembling processes, the assembling processes, and the post-assembling processes. All the three stages involve a wide spectrum of machineries and equipments, and most of them have possibilities of integrating automations. At the end of this module, you will be able to acquire knowledge on the following: the various machineries and equipments, the various automations and the software, all of which are available for the various processes involved in the apparel manufacture. So now let us have a look at the machineries and equipments in the pre-assembling process. So the first thing is the 3D body scanning technology. The development of 3D body scanning technology allows for the quick and consistent extraction of body measurements and can generate customized fit for any number of people. The measurements obtained using this technology is more precise and reproducible than those obtained through the traditional physical measurement process. The 3D scanning technologies used for body measurement extraction on today's market are based on various systems. Laser scanning technologies work on the basis of a light plane and triangulation method. In this, a laser is used as a light source, and a technology called CCD, that is couple charge device, scans the field of the view. The CCD detects the displacement of the light on a body. Body scanners based on laser technology are able to scan about 60,000 points per second. So this diagram explains the whole process. The person stands in a cabin, and the person's body measurements are scanned, and the final thing you'll be able to see that there is a dummy which is getting created, and all the measurements are extracted from the body. So the next thing is the fabric defect checking, which is again another important technology which is involved. So all the fabrics have to be defectless. So for this we have a system which checks these defects. Portion of defectless fabric is first scanned and stored as a standard raster image for reference. Roll of fabric is exposed to image processing setup where camera starts examining the fabric little by little. Sensed image is translated to digital image by analog to digital converter. And the sensed image is compared with standard image using algorithms and filters. For example, there is one kind of a filter called the low pass filter, which differentiates the fabric portions with different light intensities. So the portion which has more light intensity, it shows that there is a hole. So that's how a hole is detected in the fabric. So like this, we have a lot of algorithms and filters which work on finding out different kinds of defects. And finally, the software is able to give us the details of the defects with a lot of technical details, including the position where the defect is found in a fabric. So these algorithms demand large processing time and hence require special purpose powerful processors like parallel processing hardware like transputers or a PC with a frame grabber. So finally, the digital image is converted to analog image to be displayed on the monitor along with the technical details of the identified defect. So this flowchart explains the whole process of the defect checking software. The next one is computer-aided designing software for garment designing. The first thing is all about pattern design and pattern making software. The most popular CAD software which is used for garment design, it has a combination of 3 modules. It has pattern making, grading and lay planning software. The pattern making software allows the designer to create basic patterns. The designer can then modify the patterns by flat pattern techniques and introducing style lines according to the design required. In the grading software, the prepared patterns can be increased or reduced to required sizes in order to facilitate for better size customization in the mass production. And coming to the lay planning software, in a marker planning software, it attempts to minimize the amount of fabric wastage by placing the various graded patterns on a length of fabric as compactly as these figures explain the grading and the marker planning. The next is a virtual prototyping. It looks as though magic is happening. So here, the virtual prototyping is a computer-based technique which involves computer-aided design and computer-aided engineering softwares to validate the design before making a physical prototype. Involvement of 3D technology ensures the fit of a garment to be as closely possible to its target customer. The virtual making of sample contributes to reducing the number of samples required and their associated costs. Spreading is a process of unwinding large rolls of fabric onto long wide tables as defectless and tensionless fabric plies in order to prepare the fabric for cutting each piece of a garment. Fully automatic spreading machines have automatic loading or unloading device for fabric rolls, automatic roll turning arrangement for face to back lay, automatic leveling device for fabric edge alignment, automatic cutting device at the end of a run, automatic tensioning device to control the fabric tension, automatic lay height sensing elevator, and programmable lay length, ply height and step lay. So all these are available in automatic spreading machine. So that's an example. That figure shows the example of a spreading machine. The next process is the fabric cutting. Cutting is a process where fabric is cut out into pattern pieces to be assembled as garments through various assembling methods. Types of fabric cutting machines, we have semi-automatic or fully computerized, and we have another classification of these cutting machines. They are either portable cutters, something like straight and round knife cutters, or we have stationary cutters like band knife, die cutting, servo cutting, plasma cutting, water jet cutting, or laser cutting. And then we also have position markers. These machines actually help us to mark notches, drills, and thread markers and all those things. So that's an example of a cutting machine. And the next one is the cut order planning software. So here, the cut planner takes a customer's order for a clothing item and creates a cut plan including different sizes and different fabric types or the colors for individual markers. The objective of cut planner is to minimize the total production costs. Next one is the labeling machine. The Infomark Gerber labeler is an example for an automatic labeling machine. This automatically prints, positions and applies the labels during the cutting process. So the Infomark GTXL labeler is installed directly onto the head of the cutter. Labeling machine improves the post-cutting parts identification process. So that's an example of a labeling machine. So that's all about the pre-assembling processes. Next, we will have a look at the assembling process. The garment production process includes a set of workstations at each of which a specific task is carried out in a restricted sequence, with hundreds of employees and thousands of bundles of sub-assemblies producing different styles simultaneously. Various industrial sewing machines can sew different types of stitches. Some machines work sequentially and feed your finished step directly into the next machine. There are other processes which have multiple machines performing the same operation or a series of operations done in a sequence and then passed on to the next operation. And finally, the sewn parts of the garment such as sleeves or pant legs are assembled together to give the final form to the clothing. So here the most important in this sequence of machines, the most important one is the sewing machine. Sewing machines are categorized based on stitches formed, the kind of bed type, feeding mechanism and the lubrication system. Stitches can be formed without a material, inside a material, through a material and on a material. So stitch types are formed in three methods: interlacing, intralooping and interlooping. Interlacing is passing of a thread over or around another thread or loop of another thread. So an example for this is the stitch type 301. Intralooping, it is passing of a loop of thread through another loop formed by the same thread. So for this, an example is 101 stitch. Interlooping is passing of a loop of thread through another loop formed by a different thread. So for this, an example of the stitch is 401. These are the examples of the three kinds of stitches. And then we have the next category of machines are the stitchless forms of assembling. So we have three classifications under this. All these technologies allow for a seamless look, comfortable feel, and most of them are waterproof. The first one is welding. And the term welding refers to the thermal bonding and sealing of seams in knitted, woven, and non-woven thermoplastic materials without adhesives, chemical binders, staples, needle, or thread. The three principles of welding fabrics are heat, speed, and pressure. Thermoplastic coatings are used for heat sealing. It is done when the product needs to have special functional properties like water resistance, abrasion resistance, resistance to thread decay, and very fine appearance. So that's an example of welding. Ultrasonic sealing machine. Ultrasonic fabric sealing system bonds non-woven man-made thermoplastic materials without the use of a needle or a thread. The absence of needle holes provide no penetration by chemicals, liquids, bloodborne pathogens, or other particles. So that's an example of this kind of ultrasonic sewing method. And next is bonded seams. Bonding is a process used to join two fabrics that are non-thermoplastic, such as cotton or wool or blends, with the help of a little synthetic content. So in this process, a thermoplastic tape is placed between two layers, and as heat is applied, this tape melts and joins the two fabrics together. So that's about the stitchless machines which are available. Next one is the work aids. The work aids offer greatly to increase productivity and some to perfection and quality. The method of working of all these work aids may be mechanical, pneumatic, photoelectric, and some are electronic. Some are built into the machine, such as special motors. Some are a variation of a normal machine parts, such as special pressure foot, and some are completely separately added part. There are some examples are guides, edge guides, folders, clips, feeding devices, stackers, special pressure feet, stitching jiggers, slack feeding and elastication, computerized controls, and other equipments. So now let us have a look at the fusing machine. A wide range of fusing machine is available which prepares garment components to be sewn. Example is a collar. Fusing attaches garment component layers with three basic parameters of heat, speed, and pressure. So collars, waistbands, or non-woven backing for embroidery production are some examples, and that's a machine which helps us in fusing. We are done with the assembling processes. Let us move on to look into the post-assembling processes. So for this we have the first kind of machineries. They are pressing or finishing machines. They are generally used for finishing or decorating. Molding may be done to change the finished surface of the garment by applying pressure, heat, moisture, or certain other combination. Pressing, pleating, and creasing are the basic molding processes. Creasing is mostly done before other finishing processes like that of stitching a cuff. Creasing is also done before decorating the garment with something like a pocket, a pleats, embroidered emblems, etc. Vertical and form presses are automated machines. They perform simple pressing operations such as touching up wrinkles in knit shirts around embroidery snaps and at difficult to reach places on the garments. So this machine is an example of finishing jackets. Pressing makes a large contribution to the finished appearance of garments and thus their attractiveness at the point of sale. Steam and pressure are frequently applied during garment assembly to ensure the quality of the final product. For the opening of seams, creasing of edges, and pressing the garments with gathers and fullness, and in situations where style change is frequent, pressing with an iron is common because it is simple and flexible. Garments requiring extensive underpressing and final pressing include those that require the pressing open of seams and the setting of edges during manufacture. They are often of more moldable fabrics which use large areas of interlining and are usually wholly or partly lined. The category includes men's jackets, trousers and waistcoats, many skirts, women's tailored jackets and trousers, top coats, trench coats and other lined rainwear. Style change in many of these garments is infrequent and a range of specialized shaped press equipment has been developed. Next is automations in the apparel industry. Automation has a key role to play, enable rapid adjustments from style to style, eliminating non-productive handling of fabrics and garments, improve the quality, eliminate handling defects, eliminate manual error, accuracy in mass production, accurate reproduction, decrease the labor strain, better utilization of labor skill, etc. The various tools for automation which are generally adapted in apparel industry are computer-controlled sewing machines or pneumatics. Typically, the computer programs for different stitches are stored in removable memory disks or cartridges. The sewing machine computer may also hook up to a PC in order to download the patterns directly from the internet. They also have a series of sensors that tell the computer how all of the machine components are positioned. By precisely moving the work area forward, backward and side to side while adjusting the needle assembly to vary the stitching style, the computer can produce an infinite number of elaborate shapes and lines. The next that we are going to look at is about automated workstation. These carry out many complex functions in addition to sewing. They make use of electric, electronic and pneumatic control and incorporate sophisticated conveyor and clamp technology. Examples are patch pocket setting on jeans and shirts, run stitching collars or flaps, long seam joinings, making jetted pockets, serging the trousers, and sequential buttonholing. The operator still loads the machine and may remove the garment part after sewing, but the machine controls the rest of the handling and all of the sewing. The operator is able to undertake various handling activities depending on the type of the machine during the sewing cycle. Thus, handling time is incorporated into sewing time and the machine utilization can rise from 20%, that is typical of a basic sewing machine, to as much as 80%. Each machine carries out one basic conformation of sewing, but size or shape of, for example, a collar or a patch pocket can be altered for different sizes and styles. Automated workstations have achieved productivity improvements by increasing the speeds of the machines, numerically controlled features often combined with sensors, enabling easy maintenance of payroll, worker evaluation and reporting, attachments and work aids in order to improve the speed and quality, and requiring the operator to load and unload only, enhancing the reliability and thereby reducing the downtime, quick changeovers, and each workstation is allotted with an operation. Operations are the divisions of the total work content of the garment. Each operation consists of a work cycle, which is a sequence of elements of cutting or sewing, fusing or pressing required performing a job or yielding a unit of production to complete a garment. Programmable automated workstations could be reprogrammed and a change of garment style could be taken up for production. The next is about the microchips which are used in sewing machinery. Application of microchips in sewing machinery extensively helps to control and diagnose sewing machine functions. Some of the functions of such machines are programming stitch in pattern tacking machine, controlling the speed of the machine, programming the number of stitches in different sewing cycles, controlling the feed dog movements, diagnosing the machine malfunction area, voice activated start stop of machine, step motor for driving puller, computerized thread tension monitoring, thread brake or exhaust indicator for the needle, bobbin and looper, online seam quality inspection, fabric ply sensor, speed responsive pressure foot, elastic or tape metering device. And the next kind of a technology which is used for apparel processing is the RFID technology. So RFID is nothing but the radio frequency identification technology, which is used in various parts of apparel manufacture. So it is used in cut part identification system. It collects and analyzes production data during the entire production workflow on a real-time basis. This specifically deals with common production problems encountered on the shop floor. An RFID system not only obtains information about production quantities in real-time basis, but also traces the efficiency of each line, performance of each sewing machine and each worker. It shows who is working in which bundle, a fast resolution of bottlenecks and rapid tracing of quality issues to their source. Main components of the system are RFID software, a computer, data cable, RFID card, RFID scanner, RFID reader and a terminal to display the information to the operator. In real-time RFID system, data is captured through scanning of RFID cards or tags at the operator terminal, which is otherwise also called as a workstation. To manage the production, shop floor production information is very essential. For the purpose of line balancing, knowing hourly production and even individual operators' performance at the end of the day, the common method is capturing operator-wise production quantity manually. To replace the manual data tracking process with IT-based technology, barcode and RFID systems are available, and RFID is much advanced. Both systems have their own advantages and disadvantages. Multiple RFID tags can be scanned at a time, and RFID reader scan tags from any direction within a limited distance. Only one barcode sticker can be scanned at a time, and barcode scanner from front only. It can scan only from the front. So RFID system is faster in data capturing. In the case of installation and running cost, for barcode initial cost is less compared to RFID, but the running cost will be high in case of barcode system. RFID can be reused many times, where barcodes consumed once cannot be reused. In RFID, you will get the real-time information which enables reporting and maintaining the management information system. In case of barcode, updated production information is got only when the individual barcodes are scanned explicitly, which is generally done once in 2 hours. All these automations are steadily increasing according to the growing needs of the dynamic apparel industry and will for sure improve the quality and productivity of the industry in multi-folds. So, now that you have learnt about the various avenues where technology has been applied in the apparel industry, I think this can help you to keep track of further improvements. So, remain updated. I hope you enjoyed the learning. It's time to sign off from you.